Section 7, air conditioning, cooling. Unit 37, air distribution and balance.
Distribution.
I said distribution.
Distribution and balance.
Whatever, you gotta go. Objective, after studying this unit, you should be able to describe characteristics of a propeller and a centrifugal blower. Take basic air pressure measurements, measure air qualities, list the different types of air measuring devices.
Okay, so that word is,
Centrifugal,
No,
Centrifugal.
no, it's not centrifugal either.
it's
It's whatever we want.
Centrifugal,
I can't say it.
centrifugal.
Centrifugal. Describe the common types of motors and drives, describe duct system, explain the constitutes,
What?
I can't say it.
What constitutes?
Explain what constitutes good airflow through a duct system. Describe a return air system, plot airflow conditions on the air friction chart. Next person, I'm done reading.
Conditioning equipment. Air has to be conditioned to be comfortable. Equipment includes cooling coil, heating device, device to add humidity, and device to clean air. Forced air systems use the same room air over and over again. Fresh air enters the structure by infiltration or by mechanical means.
Okay, remember talked about infiltration? Air infiltration, you guys got that wrong in the test? Yeah.
I didn't get it wrong.
Yeah, infiltration, leakage.
I didn't get it wrong, I know what it is.
I gotta put us on blast on when the camera's recording. We all got it wrong.
When air you in over the outside to the inside of the house.
What's your name?
It's Victor. Victor got it wrong.
I got it right.
Okay, here's your first cartoon of the day.
Yay.
Infiltration, mechanical means, this is, if we're looking at a duct system, here's our duct system. We've got supply duct, and we got return duct. Are you paying attention, Victor?
Yes.
Okay, supply duct, return duct, okay? So in this duct, there is a positive pressure and a negative pressure. Can you tell me which duct has a positive pressure?
The supply duct.
Okay. Alright, so the supply duct has a positive, that means the return has a
Negative.
negative. So it's lower pressure than the outside air pressure, right? So naturally, if you put a duct on there to the outside, it will draw fresh air in because of the negative pressure. See that?
Correct air quality. The forced air system delivers the correct quantity of conditioned air to the occupied space. Different space require different air quantities. Same structure may have several different cooling requirements.
Okay, so here's floor plan. This was before I did the remodel on this house. Each room has specific heating and cooling requirements, as you can see. See that? See, 6,000 BTUs of cooling in the kitchen. And if you come over here to 6,000 BTUs, bedroom 1, 3. See that?
Mm-hmm.
So, 9,000 down here, 6,000 down here. So each room is gonna have a specific load that we've gotta address with the duct sizing.
The forced air system. Component that makes up the forced air system: the blower, air supply system, return air system, grill and registers. Occupant should not be aware if the system is on or off.
Okay, so how many of you know when your air conditioner comes on?
Yeah, you can hear it, so it's on.
Yeah, you hear it.
Wow.
Morning,
I'm gonna try that new copy.
Felipe bought all these cups.
Okay. So, you shouldn't be aware of it.
So why does it say should not be, oh, 'cause that's the forced air system. Okay. Move to the camera when you
Say hi as
On
you walk
camera.
by the
Oh.
camera.
leave.
Okay, so here's another cartoon of your duct system. This is just an example of different types of fittings, sheet metal fittings that we're gonna use, or you're gonna see out there in the field. This little box right here, on top of the air handler, or the furnace, is called a plenum. Okay, everybody say plenum. Okay. All right, so your main trunk, and as you come off of the main trunk, there are takeoff fittings, which are called takeoff. These are test questions, by the way. So you come off the main trunk onto the supply duct, it's called a takeoff. Okay, once you come off of the supply duct to the grill or the register, whether it be the floor or the ceiling or the wall, that fitting right there is called a boot.
It's called a what?
Boot.
A boot? Yep, boot.
Boot. Boot. Do you guys wanna see one?
What kind of thing?
Huh? Okay. No. Oh, here, this is a boot. Go ahead, touch it, get your hands on. Okay. Takeoff, I don't have an example of a takeoff, but some other stuff here. The return air grill, or the boot. It's actually a boot, because the duct sits on top of there, and the register grill screws onto the box itself. But this is called a return air can. Even though it's a boot, a big boot, it's a can. That's just what they call it. Here in present. Okay. Here's a couple of different types of boots. The PH1 is the one that taps around. The PH2 goes off to the side, and the PH3 goes off at an angle off the end.
So we were looking at a PH1 just now.
Yeah.
The blower provides the pressure difference to force the air into the duct system through the grills and registers and into the room. Pressure in the ductwork is measured in inches of water column in WC. Air pressure in the ductwork is measured with a manometer. System pressures. Duct system is pressurized by three pressures: static pressure, air pressure in the duct; velocity pressure, pressure generated by the velocity and weight of the air, total pressure. Static pressure plus velocity pressure equals total pressure.
Okay, we kinda went over this a little bit last week about the pressures in the ductwork, velocity and static, and total pressure. So basically, static pressure plus velocity pressure is gonna equal total pressure. So we're gonna have velocity pressure and we're gonna have static pressure. Okay? Wow. And there's an example of static pressure.
Morning, Josh.
Static pressure is actually measuring the pressure in the ductwork itself. That's what it's like. It's the pressure of the air duct and the air in the duct, right? Okay, so in order to get velocity pressure, they're measuring total pressure by this tube, and they're subtracting static pressure. See how that manometer is configured? So you got pressure on both sides of this U-tube. Okay, so that's how they're gonna get velocity pressure. How they're gonna get total pressure, here's just like this. They push the tube in there, and it's gonna get the total pressure of the air and the velocity, the static and the velocity. That make any sense? Good. How they measure it? Yeah. Okay. Great. We're gonna measure our air system with a Magnahelix. I have one back there. These are pretty sensitive. They will measure in inches of water column. The actual water column in inches you'll use in the advanced lab. They have a lot of them back there. So you just put water in a column in the U-tube, in a column, and the pressure will push the water level up and down, and you'll measure that. That's where they get the term water column. Okay? And if you don't have a Magnahelix, you can get a Kelmahelix.
Is it more accurate? Yeah.
Does it really
What's the
offer
difference
it?
between?
Uh-huh.
Count. Anything with count's supposed to be good. Your kids, you always wanna get count tools.
Oh.
Air measuring instruments for duct systems. Velometer measures air velocity, how fast the air is actually moving in the duct. Air volume in CFM can be calculated by multiplying the air velocity by the cross-sectional area of the duct in square feet. Input tube, used with special manometers for checking duct pressure.
Okay, new words. We got manometer, right? Pitot. Pitot. It's French.
Oh.
Propeller fan. Used in exhaust fan and condenser fan applications. Will handle large volumes of air at low pressure differentials set into a housing called a venturi, which forces airflow in a straight line from one side of the fan to the other.
You guys are already familiar with this? What does that look like to you?
Okay.
Okay? Yeah?
Yeah.
Have you ever dealt with a fan like that?
Many times.
Many times, huh? The radiator. Whoa. So the radiator fan, this pushes air in a straight line. It's good for, like I said, it's good for large volumes of air with no static or minimal static pressure. Okay?
Types of fans and blowers continue. Squirrel, cage blowers, and forward curve configurative. What's a centrifugal blower?
Yeah.
Desirable for ductwork, built more pressure for the intel to the outlet. Has a forward curve blade and a cutoff to shear the air spinning around the fan wheel. can be used in very large, high-pressure systems.
There's your cartoon of the squirrel cage blower. Have you seen any of those? Have you ever seen those before?
Yeah.
Hey guys, what is it?
Yeah.
Bounce house. What'd you say? A bounce house?
Oh, yeah.
Okay, there are water coolers. Here's a small one. Got a little small one here. As you can see, inside it's got a squirrel cage. Motor on the outside here. This part right here, what they're talking about is the shear cutoff. It's this point right here where it actually cuts off the air at this point. If you didn't have that, that air would kind of just keep circulating around that wheel.
Makes sense.
Okay, who wants hands on? You want hands on?
Forgot to show the people on the camera what it looked like.
They'll get hands on when we get the light.
Oh, okay.
This is the type of blower we're gonna use for ductwork. This works well for ductwork. The propeller fan will not work in ductwork. You just can't push against static pressure. These can push against static pressure.
Types of drive assemblies. Belt drive blowers have two bearings on the fan shaft and two bearings on the motor. Motor pulleys and fan motor pulleys can be adjusted to change fan speed.
Where's the squirrel, Steve?
Direct drive motors use no pulleys or belts and can be multi-speed motors. Speeds can be changed by changing motor wire leads.
Okay, so there is no squirrel. It is a squirrel cage.
Okay.
Could a squirrel get in there hypothetically?
No, that's what they keep.
Depends on what horsepower you
Okay.
want.
I mean, it could, might be a little messy.
The squirrel got away.
This thing is useless.
Okay, another cartoon of your belt drive squirrel cage motor. Does that remind you of anything?
Looks like that little 40 thing that we had, a little belt on it.
No? Okay. So this is typical for, evaporative coolers. Also commercial blowers.
The supply duct system distributes air to the terminal units, registers, or diffusers in a conditioned space. Duct system, plenum system, extended plenum system, reducing plenum system, parameter loop.
Okay. So we're gonna talk about different types of duct systems.
The plenum system, suited for a job where the room outlets are all close to the unit. Supply differs are located on the sidewall. Work better on fossil fuel system. Fossil fuel supply air temperature could easily reach 130 Fahrenheit.
Okay, this word right here,
Diffuser.
diffuser. Diffuser. Okay. It diffuses the air.
Like an oil diffuser.
Yes. Okay, so the plenum system looks like this. Check it out. Got the plenum on the air handler, and you got all the ducts coming right off of that plenum. Just basically a plenum system. Suitable for smaller environments. Okay. You'll see the difference when we get into the other ones.
Hey, quick question, if we're replacing a whole AC unit, are they supposed to are we supposed to go in there and look at the duct system and make sure that's all good as well inside the
You're
home?
required to.
No, I didn't do that part.
You're required to, actually, you're required to get a duct pressure test. According to the state of California. US government, they want you to make sure that there's no leaks or minimal leaks in that duct system.
And to do that, is that something you do on top of the roof, or do you have to actually go inside the attic and?
You gotta go in downstairs, you gotta go in the house to do it.
Put it on the.
Yeah.
The extended plenum system can be applied to a long structure. This system takes the plenum closer to the farthest point, called the trunk duct system. Ducts called branches complete the connection to the terminal units.
Okay, so as you can see in the cartoon here, it's the plenum that they've extended out to the furthest parts of the structure. So they've actually taken the ducts off of that plenum, no matter where it is. Okay? It's typical in commercial, they're gonna do this a lot in commercial. Not so much in residential. They're gonna use round instead of square, probably in residential. Okay.
The reducing plenum system, reduce the trunk duct size as branch ducts are added. Has the advantage of saving material and keeping the same pressure from one end of the duct system to the other.
Okay, so the reducing plenum system. This is the most popular, and this is the one you're gonna learn how to get these sizes. And they're all different. Notice that they're all different, right? So in order to get those sizes, we're gonna have to figure out and calculate that. And then, again, this is the most popular that you're gonna see out there in the field. Okay, you happy with that so far?
Why are they different size?
Did you ask why they're different sizes?
Yeah.
Because they're different sizes.
To keep the same pressure from one end to the other. Okay. So whatever pressure you got in here, in that 18-inch, you're gonna have the same pressure right there, that 8 or that 6.
The perimeter loop system, well suited for installation in a concrete floor and colder climate. Warm air is in the cold loop when the furnace fan is running. Keeps the slab at a more even temperature, provides the same temperature to all outlets.
Okay, so the perimeter loop system. You're not gonna see this here. No, you won't see this. Okay, so the loop system, it said, well suited for installation in concrete floor in a colder climate. Do we have a colder climate here?
No.
No, we don't have.
So like Alaska would have this. Idaho.
New York, Maine.
New York.
Oh, so cold.
So, and the reason why the perimeter loop system, you will find ducts in the floor, but they're not a loop system, they're not perimeter. So, the reason why they have this extra loop in here is to keep that ductwork and that concrete slab warm in the wintertime. So you got warm air going through there, and you can imagine if it snows 5 feet, let's say, 5 feet of snow backed up on the side of this wall, that cold air is gonna try and, the hot air is gonna try and get to the cold, so you're gonna have a big problem in the wall there, where you're gonna get you can get drafts and stuff like that, because the heat's gonna try and go through that wall. So once they keep the perimeter of that slab warm, that keeps that cold air from coming in through the slab.
Makes sense. Smart. Ooh, bless you.
Duct system standards. All localities have minimum standards for air conditioning and heating systems. The regulating body might use a state or local standard or adopt other known standards. These are called codes. Code requirements are not standard across the nation. Duct materials. For years, galvanized sheet metal was used exclusively. Other ductwork materials are aluminum, fiberglass, ductboard, spiral metal duct, and flexible duct.
Okay, so for many years, it was galvanized ductwork in the attic, hard pipe. And it was wrapped on the outside with insulation. But now, all new construction is hard pipe. Okay, so if you're doing new construction, you're gonna be running a hard pipe. Okay, I didn't let you know that. We'll go over these.
Galvanized steel duct. Gauge is a measurement of the thickness of galvanized steel duct. The gauge size means how many pieces of that material would need to be stacked together to make a 1-inch stack. Metal duct can be round, square, or rectangular. Fiberglass duct. Styles, flat sheet or round prefabricated cut. Duct is normally 1 inch thick with an aluminum foil backing. Special knives are used to make special cuts to turn duct board into ductboard. All duct seams should be stapled and taped.
Okay, so they're talking about this page 111 in the book. They're talking about fiberglass duct board. If you want to look it up. Now the duct board itself comes in 4-bag sheets, and you fabricate it on the job as you need it. Or I guess you could fabricate it in the shop.
You said page 111?
111. 11.
111.
On the right.
I don't think it's
You
page
sure that's right,
111.
Steve?
11, 12.
What is it?
12.
Oh, 1112.
11, starts on 11.
What are we talking about, the tool or the fiberglass?
The duct itself.
11.
Oh, 1111. Oh, we're way up there. Here, I was on 111. Oh,
Yeah, but we already learned about
I was about to say.
Yeah.
There you go, you're right.
Sorry, my fault. Okay, this has, you'll find some of this out in Fresno, but not very much. It didn't quite take off like they thought it was going to. It's possibly because of the tools that you have to, purchase in order to fabricate this stuff. You got different types of cutters and knives that cut different, joints, so they can be stapled and taped together as you form boxes, squares, stuff like that. See that on page 1113? Wow, okay.
Spiral metal duct, used on large systems. Comes in rolls of flat, narrow metal. Runs can be made at the job site. Can be located within the occupied space for a more contemporary look.
Okay, so what are they talking about, spiral metal duct? There it is.
Industrial look.
Yeah. Industrial or contemporary.
I like industrial.
Yeah. This happens to be at Pyology.
I like that.
Okay, that could be a cahoot person.
Pretty good, actually. Yeah.
And there's some more.
I like that.
This has to be Taco Bell.
I can see by the colors. Did you take these pictures?
Yes. I
Awesome.
did, that's what I do.
You take pictures?
You're like a real natural photographer, aren't you?
I noticed the ductwork, so I figured
Oh, I thought you did the duck work and then took a picture, but, oh.
no, I was eating lunch there.
Oh, okay. Did you have that burrito green sauce on it? Yeah.
Yeah.
Really captured the natural light, good.
That yellow really makes it pop.
And it's something that you will get used to doing.
Taking pictures or?
Noticing the ductwork. Once you work in the trade, any amount of time, you're gonna see stuff that normal people won't see. Normal people. But we're actually the normal people because we notice things. Like every time I go into a restaurant, I always look at the ductwork. Why? It's my job. It's my job. I always look for the location of the thermostat. Where's the thermostat located? Where are the ductwork? What kind of registers are there? Is it exposed ductwork like this?
How often are you like, oh man, they did a shit job?
Oh, a lot.
Not very. It's usually done pretty good. Types of registers, stuff like that. Always constantly looking at the ductwork and air conditioning units on roofs in residential areas. I can tell you what type of unit is on the roof just by looking at on the street. And I know how to get into that unit if it's 1/4 inch, 5/16 screws, 1/4 inch screws, cross point screws, 3/8. And you'll get like that too. You'll be like that.
Flexible duct, comes in sizes up to 24 inch in diameter. Some have a reinforced aluminum foil backing. Some come with vinyl or foil backing and insulation on. Keep duct runs as short as possible. Has more friction loss than a metal duct. Flex duct should be stretched as tight as possible. You don't want those loose walls.
Flex duct.
I don't like this stuff.
That's what we have back here, right?
Well, you're fucked.
Right there.
What is that one, loose? No walls?
That's flex.
Oh, okay.
And here's a cartoon of installation of flex duct. As you can see, off of the plenum, there is a, what kind of collar?
Oh.
Okay.
Oh, collar,
Collar.
What kind of collar?
a takeoff collar.
Takeoff. And this is a plenum, right?
Love it.
Mm.
That's probably not good, right?
Right.
I feel like that's gonna cut off my airflow.
This might be some problems you might have.
That's because the strap is too tight, I'm assuming?
No,
Oh,
that's because there's only one strap, and there should be
couple,
multiple straps, kind of like this.
like that.
Mm.
Oh.
Because it's flexible and it's gonna sag, so you wanna support it.
So a thicker strap's probably better than a thinner
Yeah.
strap.
Yeah, I think the code even requires 2-inch straps in present, so.
So you kinda wanna keep some open walls up in there. Open flow.
Combined duct system. Some example, metal trunk lined with round or flex branch duct, or round metal branch duct. Duct or trunk lined with flex branch duct. Round metal ducts with round metal branch ducts. Round metal trunk lines with flex branch ducts.
Okay, so all they're saying here is we can use a combination of anything to make the ducts work, as long as it's the correct size.
air movement. Branch ducts are fastened to the main trunk by a takeoff fitting, which encourages the air moving down the ducts when to enter the takeoff to the branch duct. Air moving in the duct has inertia, meaning it wants to move in a straight line. Using turning vanes will improve airflow around corners.
Okay, so turning vane, I don't know if they have a picture of that, I think we do.
Yeah.
Okay. Oh, there it is. Page 1118.
11:18.
Turning vane,
Oh yeah, look at that.
huh? See that? See how it makes those, you know it's correct, because it's got a cartoon of swirlies
Yeah.
on the figure 3765. And then on 3767, all those little curlies are straightened out. See that?
Yeah.
And then the turning vanes itself are figure 3766. And they're generally in the corner of square ducts. Okay, so nobody told, oh, there's the picture there. I didn't know it was in there. Okay.
That's what you think.
See all the swirlies? Okay? So nobody told this guy or Bruce Willis crawling around in the air duct that they're turning vanes in the corners. Okay?
Just ruined that hard for me.
Balancing dampers, used to balance the air in various parts of the system. Dampers should be located as close as practical to the trunk line. The trunk is the place to balance airflow. Handles allow the dampers to be turned at an angle so the air streams to slow the air down.
Okay, so not much on residential, but a lot on commercial, they're gonna put dampers in, like up in the attic. So you will find them, usually they'll tie a, plastic ribbon to the handle, so you can find them after the duct's already sealed up. The, outside, insulation has covered the entire duct. So they'll leave that ribbon out there so you can reach up in there, turn it. Most commercial, buildings will have that, and some commercial buildings and some contracts actually require air balancing by certified air balance company. So they'll go in and certify the air, the correct air is going to each space according to the prints, and then they'll certify it. Piece of cake, huh? I've done air balancing. We weren't certified, but we told the customer that, actually, with Keller Motors, Hanford. He called up, he had airflow problems, and he said, I got airflow problems, can you come and do an air balance? And my boss says, yes, we can. We're not certified, but we can, if you have the plans, we can do a air balance for you. So I took me and another guy out there, and we looked at the plans, and then we opened and closed all the dampers and balanced each one with the air, the flow hood. And, we got it according to the plan. So nobody had done an air balance in that place.
So, what is, I mean, obviously, I know what certified means, but what's the difference of being certified? I mean, what, you just can't get on paper saying you certified it, that's correct, or?
Right.
Okay.
Right, yeah.
So
If
it's
it's
kind of-
required certified air balance, you have to have a certified air balance company
Okay,
do it. Like a smog check, a smog certified smog thing for your car, right?
zoning. Another type of damper is the zone damper. Open and close in response to changes in room temperature. depending on whether or not the temperature required for the zone are satisfied, can be pneumatically, air, or electrically controlled.
Pneumatic.
Pneumatically.
Everybody know what pneumatic means?
Yeah.
There you go.
Pneumatically, is that what it
Yeah.
is?
What is it? Pneumatic.
Air.
Air.
Like air tools, pneumatic tools.
Well, pneumatically means it's controlled by air
Say
pressure.
it again?
Yeah. Air pressure.
Air pressure.
Pneumatic.
Pneumatically?
Pneumatic.
The P silent.
Oh, pneumatically.
There you go. There's a
Is it
whole,
though?
Pneumatically.
there's a whole plethora of pneumatic controls out there. And a lot of buildings downtown were done in pneumatics, which means they don't have any electrical wires going to the thermostats or the valves or anything. It's all done by air pressure. So that controls everything, is the air pressure. It's a complete science as far as, a branch of air conditioning. It's basically not that hard, and it's not that, difficult to understand. Instead of using electricity to the thermostat, they use an air tube. And the thermostat will sense the air pressure, and it will adjust the air pressure to whether it needs, heating or cooling. Wow. Here's a zoning cartoon. Zones have control panels, and they have different, thermostats for each zone. And each thermostat controls a damper. See that? That's pretty simple there. It gets pretty complicated when you get into commercial. Like this particular, zone here. Got an air damper, air handler, and you got 2,000 cubic feet per minute going down the duct, feeding 4 zones, right? Check it out. As the zones start to satisfy their temperature, they start to close off. And now you have 2,000 CFM.
Thank you.
The 2,000 CFM trying to go down through a duct that can only handle 400 CFM, so there's a problem there. So all zoning systems are gonna have what they call a bypass duct. So that allows that extra airflow to go right back to the air handler. So unless that system has variable speed blower, if it's got a single speed blower, it's gonna have a backflow or a bypass damper somewhere. Yeah.
Exciting.
Let's not all read at once.
Zoning with a multiple speed compressor and a variable speed blower. Uses computer controlled panels to regulate the requirements for each zone. Example of data usage. Return and supply air temperature, airflow requirements for each zone. Percentage of airflow for each zone as a percentage of total system airflow.
Okay, so these are just all inputs that the control panel is gonna see. It's gonna check a bunch of different things inside that ductwork to determine whether or not the damper's open or closed, whether you got your bypass damper and how much your bypass damper is supposed to be open and stuff like that. And again, I shouldn't say bypass damper, because if you're zoning with a multi-speed compressor and variable speed motor, blower motor, you're not gonna need a bypass damper, because it's automatically gonna ramp down and reduce the flow of air. And if you ramp down the blower, obviously you're gonna have to ramp down the compressor too. You're gonna have to find some kind of capacity control for that. So in this case, it's multi-speed compressor, or it could be a bigger compressor with unloaders, some sort of capacity control.
Adding zoning to an existing system. Retrofitting existing systems has become a very popular option. Compact, easy to install dampers are available in various configurations to fit into existing duct systems.
Okay, we've done this a lot out in the field, where we actually needed to put a zone in. So we've actually, I'd actually go out there, measure the ductwork and tell them what I needed, and they'd get the kit together and they'd send it all to me, and we'd go out there and install it. The only thing we needed to do was put in a transformer and a thermostat. They generally would set a thermostat, but we still have to run the wires. And we'd install all of the dampers that we needed, and they were good to go. Ready to keep going.
I should probably do this to my garage.
Oh, yeah.
To your garage,
The garage,
what do you want air conditioning in your garage for?
okay,
So it could be cool.
we'll talk about that. We'll talk about that.
Now when he gets in trouble, he doesn't know these.
Okay, break time.
Break time.
Break.
Break.
Cause I wanna have it nice and cool in there.